Well, good afternoon, YouTube. It's been a long time, about a couple years since I've been making videos about electric lighting, and had a run-in with another collector. His name is Banilla. He's got his own street lighting group, and he had obtained enough information off of my videos to actually contact my job and have me fired for taking stuff out of the dumpster. And the past couple years, I've just been really scared to make any kind of videos with people like that out there. The guy's absolutely batshit crazy, as some of you may know, but I feel like it's not fair to the other collectors to not share this information. And I'm just kind of starting out by making a couple videos and getting back into the swing of things. And one thing that I really would like to share with everyone is this F85T10 Rectified Fluorescent fixture from the early 1940s. And I did have some videos of this fixture before, but I was, like I said, I took all my videos down because of that Lester Banilla guy who's absolutely nuts. And I'm going to just start getting back out there, and I'd love to share some of this really obscure technology with you, how it works, theory of operation, and then lastly, the most fun part, putting some voltage on it. So this particular fixture you see here came from a scrapyard in Mount Pleasant, Florida. Numerous collectors are aware of this find. Roger Huffman, shout out to you for actually years ago meeting me when it was 95 degrees outside and climbing through these attics of this military surplus place called Paramore Surplus, which I'm going to put some pictures of. It's a really cool place. And salvaging these fixtures, there's a very small handful of them in collectors' hands. And they're just really cool. So to start off, why rectified fluorescence? So what do we mean by rectified? Well, we mean by that by taking alternating current and then using the tube here as a half-wave rectifier to produce a flicker-free fluorescent tube, for obvious reasons, which I will go into. You can see that the tube here, this is a Westinghouse one. It's got nickel end caps. So it's from the 40s. I got a few of these tubes, and they're really well made. But one end of the tube has 3 prongs on there, you can see. And this particular end is the filament end. I have one of these cracked open. I'll put pictures on the video where you can see the electrodes. I had a tube that lost vacuum, and I broke it open to see what the electrodes. And then the other end is a 2-prong end, which is it's connected to 2 electrodes that are made of some type of ferrous material. It's about a cylinder. It's a cylinder about 1/4 inch wide by 2 inches long of some kind of ferrous material. And those are the electrodes for the tube. It's a T10, so it's, that's the width of the tube, but the tubes are 5 feet long. And they're rated for about I want to say 4,000 hours, and they produce about 3,000 lumens. So they would last not very long on day service, but this is the 1940s. That was just the technology there. So earlier I did mention that this rectified fluorescent, it's taking alternating current and turning it into direct current. Well, why would you want to do that? So you're producing a flicker-free fluorescent light source, and these RF fixtures were only available for sale between 1938 and 1942, early 1942. The U.S. military actually issued an order that no more RF fixtures were to be made for World War II because they just took so much metal. As we're going to see later, as we examine the ballast, they just took a shit ton of copper and steel to make the ballast in comparison to your T17 fixtures, which had significantly smaller and less complex ballast. But like I said, flicker free. So why would you want a flicker free fluorescent light source? So A majority of all these RF fixtures are strongly associated with the U.S. military manufacturing plants. And if you had a piece of machinery that spun or operated at a denominator of 60 hertz, because the lamp is flashing 120 times per second, the machinery would appear completely stationary. And if you had a spinning piece of machinery that didn't appear as though it was moving and somebody touched it, it could rip your arm off, kill you, lacerate you, etc. So it was very, very important to have a flicker-free, energy-efficient light source. And like I said, all the pictures that we have found of these rectified fixtures are in military manufacturing factories, machine shops, and they are deployed in mass. I do have a trade journal, which I'm going to show that article, where they do specifically mention that about 600,000 of these RF fixtures were made before being discontinued. And ironically, in collectors' hands, there's less than like 10 working fixtures out there. But, you know, as we spread the information and the more people know about these RF fixtures as they turn up, they can potentially be salvaged. So this particular fixture here is a Westinghouse model. It has 2 tubes in it, and I believe it's from 1940 to 41 based on the labeling. And these things are built like a brick shit house. They are very, very heavy, very, very well made, incredible fixtures. Adjusted for inflation, the price came out to be about $660 per fixture in today's money in 2024. So you can see it's got this super heavy enameled, beautiful, beautiful reflector. And then the top of the fixture, which you can see the ballast cover and the ends of it. I can't really reach up there too high because I'm only holding this with one hand and I don't want to die. And the tubes, the characteristic of RF technology fixtures is that the tubes use these plugs on them. No other fluorescent tubes, to my knowledge, has these bakelite plugs on them for the lamps right there. They're these really nice little plugs. And then, of course, you have your tube holding mechanism there that no other fluorescent fixture that I know of uses anything like that. And they're just really, really cool fixtures. I do not collect fluorescent lamps. Believe it or not, I don't collect them. So please don't accuse me of being a fluorescent lamp collector. I just, during my childhood, when I saw these at the surplus yard in Mount Pleasant, Florida, was entranced by them because of the weird, creepy blue hue that the industrial white encompasses. And they're just, they sound weird. The fixture is very loud, and as the tubes on the ends of them start to wear off on the cathode side, the phosphor gets blasted off, and you can see the eerie blue light. So here's a Westinghouse fixture with the ballast cover removed. We can see some labels here. Westinghouse S-1217-240 high power factor ballast unit for 185 watt type RF fluorescent lamp, and a bunch of other information right there. We look at that, 12441, which is when this capacitor was most likely made. The ballasts have a wave splitting circuit to jack up the voltage to about negative 300 to 300. So it's about 600 volts across the tube to start it. And then you have a tiny little capacitor with the starting coil right there, if you can see. So this ballast, here's my little hand right here. You can kind of, my girly little dainty hand, you can see how big this thing is. But these ballasts on these things are fucking huge. They're massive, and that's why the U.S. military didn't want GE and Westinghouse and Benjamin making these things. There's only 3 manufacturers that we can identify so far. GE was the first one as a continuation of Cooper Hewitt technology. The circuit on these is basically the same as a Cooper Hewitt lamp, but they got the idea of improving the color by sticking phosphor on the tubes And if you watch my video about that Cooper Hewitt lamp, you'll see that they're sharing a lot of similar components between the fixtures. But you know, just look at that ballast. It's so big, and it's very tedious in how it's made with all the connections. So, you know, this was one of the fixtures from Mount Pleasant. You can see how they hacked it together and did all these modifications to it to keep it running. The guy that owned the place was a hoarder, and I'm very lucky that he was, because these fixtures really are cool. So that's the ballast right there. Here's the label on the outside of the fixture. You can see it says Westinghouse Fluorescent Luminaires, and the style number, amongst all the other information, that style number could probably yield some catalog information possibly one day, but it says style 1217236-A right there. And up inside it, you can get a better idea of what the original paint color was. It's like a metallic grayish silver color. And that ballast cover, it's just really thick metal, very well made, just like everything else. Here's a Benjamin RF fixture that was recovered from Powell Valves, just to kind of illustrate how these little plugs look for the lamps. This is the 3-prong side. They all say GE because GE was the first one to do it, and then they started licensing their technology to the other firms. Here's the 2-prong end right there. That plug right there. There's really cool fixtures. So now that we went over the theory of operation outside and inside of these things, here's the most exciting part, where I shut my mouth and actually put some voltage on these things. And you can see and hear what these fantastic and very obscure fluorescent fixtures sound like when they start up. So I've got the plug in my hand here. I'm going to try to get in a good shot so you can see both ends. These RF fixtures, when the tube's kind of stubborn to start, are a real kick. They stutter and make this really weird starting noise that no other fluorescent fixture makes. But it's really hot out here, so I think there's a lot of mercury in there, and it's going to start right up. So anyway, 3, 2, 1. Okay, so one of the tubes is being stubborn. It doesn't want to start. But my phone's not really doing a good job of capturing the bluish, eerie green color temperature. All right, let's see if we can get this other tube to cooperate. It started up when I tested the fixture for the video, but of course, I guess it's got stage fright. See inside of there where some of the phosphor is missing. It's just this eerie blue light. It's weird. Ooh, there we go. Just had to jiggle it a little bit. You can see that there's a shit ton of mercury in there condensed. These tubes are definitely loaded up with mercury. You can see where it's condensed on the bottom part of the tube. Look at the banding there. It's just really cool. Just a side note that these fixtures, when they're to be mounted, you can't really see how I've done it, but they have to be mounted at, see how it's at a slight angle? Because the mercury migration, they have to be mounted at a slight angle, so as the mercury migrates, it drips down back to the positive side of the circuit. You can see I've never seen any other fluorescent tubes do this, but the banding on this end, and when they get really high hours, all the phosphor gets blasted off, and you can see the beautiful blue light inside of the tube. They're just really cool fixtures. I wish more of these were in collectors' hands. I actually have a little brochure from Westinghouse where they mention about 12 different model numbers of RF fixtures. Of course, you're gonna have your single tube models and then your double tube models, but then they had some explosion proof stuff, which who knows if that'll ever surface. I don't know. I just love the way they sound and look. They're just very cool fixtures, and plus being historical with the World War II effort. So you can kind of get an idea. I couldn't imagine being in a factory with thousands of these things, hearing them all run at once. A lot of people, I did find another trade journal article where the people in the factory mentioned that they absolutely fucking hated these fixtures. The color temperature, they hated the ghastly blue light. And it mentioned retrofitting them to F40T12 stuff, and they had a lot of good results with that. Really cool fixture. Let's see if I can turn it off and get it to start up one more time. Usually you have to wait about a minute for the tubes the capacitor to reset, discharge or whatever. It won't start back up. Let's see if I can get it to start back up one more time. Oh, there it did. It kind of shuddered there for a second. Pretty cool fixture. So anyway, I hope you enjoyed seeing this part of the fixture. I'd like to go over some trade journal articles and some advertising for these fixtures to kind of give you a whole spiel on the rectified fluorescent story. So let's check that out. I found this little piece of paper in a case of F85T10 Rectified fluorescent tubes. It's from Westinghouse, essentially stating that you have to use the right lamp with the right ballast or the damn thing's not going to last as long or get destroyed. Of special attention is at the very bottom where it has several different model numbers of rectified fluorescent fixtures. Here's a selection of various different tubes by Westinghouse, General Electric, and a later Westinghouse model with the bakelite end. You can see the differences between the generations and manufacturers. The GE ones and Westinghouse ones are very similar. I had a tube that lost vacuum and I broke it open to kind of display the differences on the electrodes. The two-prong end is going to be on the left. Those cylinders on the end are some type of ferrous material, and the three-prong end has the filament with the special emitter material coated on it on the very right side. That gives you an idea of what the electrodes are. On the two-prong end with the two cylinders, there is a piece of stainless, presumably, that separates the two. It's not electrically connected to anything. I'm not entirely sure what it does, but that gives you an idea of what the electrodes look like. This is the actual fixture as found in the surplus yard in Florida. You can see various different pictures of the fixtures scattered throughout the facility, hidden up in the rafters. Let me tell you, getting these things down that summer day, me and Roger was absolutely hellacious in that 98-degree weather. But it's really neat to see these things in use and where they were stored. Luckily, the owner was a pack rat and kept everything. We were able to recover a case of these F85T10 lamps. Interestingly, you can see it says Pensacola, Florida as the address, which is a military base. Like I said, a lot of these rectified fluorescent fixtures were strongly associated with military or war effort manufacturing operations. Lastly, we've got some trade journal information from General Electric. This is the single tube CH100, the dual tube CH200 RF fixture, and GE bragging about the progress from Cooper Hewitt to RF technology, and a little bit of information about how they work. Really interesting to see the mass deployment of these fixtures in these factories. It's so unfortunate that more of these fixtures haven't survived, but I believe that gives you a pretty good idea of the story of rectified fluorescent, and I'm hoping in the next couple decades, as more information on the internet gets out about these RF fixtures, that more of them can be salvaged, because they're really neat and unique fixtures and very historical. They have a close tie with World War II and our country's military and manufacturing prowess and lighting up these factories to keep them going 24/7. So essentially, RF technology kind of helped us beat World War II, so to say. So I hope you enjoyed this really, really long video about fluorescent lamps, particularly the RF ones. So until next time, I'm going to be trying to make some more videos and just get the information out there about these unique sources of light. And until next time, I'll talk to you later. Bye-bye.